All right, guys, let's knock out this practice test. Number one says find the common ratio. Common ratio is just R. Remember how we find R? Sometimes you can tell by looking at the sequence. Other ways, you just put the second number over the first one. So if you did negative 27 over 54, you get negative 1/2. That's all you got to do. The eighth term of a geometric sequence, I'm looking at that formula right there. The eighth term is the first term, which is 3, times R, which is also 3 this time, to the n minus 1 power. N is 8, so n minus 1 is 7. So I'm going to punch in 3 times 3 to the 7th power. I'm getting 65, 61. Okay, so it's number 2. Number 3, find the nth term. Remember, when it says find the nth term, you're going to have an n in your answer. You're just basically coming up with a formula. So just use the formula and leave the n in it. Okay, so the nth term is the first term times r to the n minus 1 power. R in this case is 6/12, which is 1/2. So I'm going to put 1/2 in here to the n minus 1 power. And guys, that's it. It's the formula for the nth term. That's all you do. You plug in your a1 and your r. That's it. Now you can check it. The second term is 6, which means you should be able to plug in 2 in for that n right there and get 6. And just looking at it, you will. So that's good. Number 4 says find the sum of the first 7. And it's geometric. So that is the sum formula over here. Okay, that's the sum of geometric. So I'm going sum of the first 7 is the first term times 1 minus r. R in this case is 2 to the 7th power over 1 minus r, which is 1 minus 2. So I know the bottom of that fraction is negative 1. The top I'm punching in right now, 7 times 1 minus 2 to the 7th power. If I could fix it, plug it in correctly. And I'm getting negative 889 on the top. And if you divide that by negative 1, obviously you get just 889. All right. Number 5, find the sum of the infinite geometric, if it exists. Now, remember, it only exists if r is between negative 1 and positive 1. In this case, r is 3/6, which is really 1/2, which means you can do it. Now, the sum of the infinite is that last formula. So it's going to be the first term, which is 6, over 1 minus r, which is 1/2. That would give me 6 over 1/2. And if you work that out, you would get 12. Number 6 is a sigma. And I'm going to write the first 2, 3 terms here. Like if I plug in 1, well, let's just do this. It's geometric. It's geometric because there's an exponent. That makes it geometric. So I'm using my sum formula. There's 11 terms. To get the first term, I'm going to take the 1 and plug it in. If I plug 1 in there, it'd be 2/3 to the first power, which is 2/3. If you do 2/3 times 15, that's 10. So the first term is 10. 1 minus r. R is the 2/3 to the 11th power over 1 minus 2/3. Be so careful how you punch that in. Okay, on my denominators, it's going to be 1/3. I'm going to take a second, punch in the top. Punched it in. I got like 9.8844. It just kind of keeps going, 3, 8, all that stuff. So to finish that, I'm going to divide it by 1/3, which really, think about it. If you divide by 1/3, that's keep, change, flip. I'm really going to multiply that times 3. When I do that, I get like 29.653. That's enough right there. Okay, the calculator won't change it to a fraction for you, so you're kind of stuck there. Let's look at 7. Number 7 says evaluate permutation of taking 9 objects out of 12. So that's a calculator problem. Punch in 12, hit math, go to prob. Number 2 is the NPR button. Then hit 9, hit enter, and that's huge. You should see 7. I'm trying here. 7, 9, 8, 3, 3, 6, 0, 0, which is huge. 79 million. That's all. Number 8. How many permutations or arrangements are there the letters in flower if all the letters are used once without repetition? Okay, so because all the letters are different, you're basically asking how many ways can you arrange 6 things. 2 ways you can do this. One is you can just say 6 factorial because there's 6, 5, 4, 3, 2, 1 if you arrange them, or you can also punch it in this way. How many permutations, which is the P, if you take 6 objects, all 6 of them, 6 out of the 6. So if you punch those in, go to math, prob, you'll see the exclamation point and the P. It's your choice. Should get 720. 720. Number 9. How many 4-digit numbers can be formed using these digits? Now notice there are 5 different digits. without repetition, which means you can't repeat them. If you can't repeat them and you're going to take 5, that means for the first one, well, you can do 4 digits. So it's going to be some kind of code like that. So you have 5 choices for the first digit, 4 for the second, 3 for the third, 2 for this last one. Okay, so you can punch in 5 times 4 times 3 times 2 and get like 120. So there's 120 different ways you can do it without repeating them. Now, if you can repeat them, that's a whole different thing. If you can repeat them, you can have 5 choices there. You still have 5 choices there. All the blanks have 5 choices because you can use the same digit. Like you can use 4, 4, 4, 4 if you want to. You can use them all. So it's really 5 to the 4th power, and that's going to be 625. So a lot more choices if you can repeat digits versus if you can't repeat digits, which you would expect. Number 10, how many permutations are there of the letters of the word cabinet? Now look at the word real closely. If you look at the word cabinet, none of the letters repeat. All right, so that means there are 1, 2, 3, 4, there are 7 letters altogether. You're going to take 4 at a time, and I'm using a P because it's permutations. I know that's all we've done. So what we're going to do next week is something called combinations, and you got to decide which one's which. So today everything's permutation. So your calculator, you can hit 7, go to math, prob, number 2, 4, hit enter. You should get 840 ways there. Number 11, got 3 more. We're done. It's pretty quick. This is a toughie. How many different arrangements are there letters in the word Mississippi? Mississippi has letters that repeat. And anytime you have numbers that repeat, you got to go a little differently here. So I'm going, count the number of letters altogether. I'm counting it right now, 4, 8. I think there's 11 letters in Mississippi. So you got 11 factorial. You can't do this with the P button. And then what I'm going to put in my denominator are all the letters that repeat. What I see first, I see 4 S's. I see 4 I's. And I see 2 P's. Okay, so now when you punch this in, you got to be so careful. Because I have more than one number in my denominator, you must use the parentheses. If you just punch it in like I had it a second ago without the parentheses, you'll get an answer. It's just wrong. Okay, so I'm punching it right now as I'm talking to you. I'm trying to get this. Sorry, I'm making the video last longer about doing this, but it's live TV, so it is what it is. One more here, 2 factorial. Close the parentheses. Wow. 34,650 different ways to write the word Mississippi. And that's even considering the fact that all those letters repeat, that's insane. Maybe we should have a homework assignment and be like, tomorrow, come in with all 34,000 ways you can write the word Mississippi, just rearranging the letters. That would be awesome. Okay, number 12. Find the sum of the first 150 even numbers. That would look like this. That would go 2 and 4 and 6, because these are all even, ... all the way to you get to the 150th number, not 150, but the 150th number. Right? So if you look at that, that is arithmetic. It's not geometric. It's arithmetic because the differences are the same. All right, so I'm going to say sum of the first 150 would be 150 over 2. I'm using that first sum formula, first term plus the last term. Now, I know the first term is 2. It's right there. What I don't know is what the 150th term is. So I got to come over here to the side somewhere, do the first formula. What is the 150th number? It's A1 plus N minus 1 times D. Difference is 2. And I'm punching that in, 2 times 149 plus 2. I'm getting 300. So the 150th even number is 300. That kind of makes sense when you think about it. So out here I have 75, and here I've got 302. So I'm going to punch in 75 times 302. Looking at 22,650 would be the sum. If you just add up the first 150 even numbers. All right, number 13, evaluate the sum. This is not arithmetic or geometric, so you got to actually plug the numbers in. So what I'm going to do on this one is I'm going to take the number on the bottom, I'm going to plug in 1, that's 1/4. I'm going to plug in 2, that's 1/8. I'm going to plug in 3, that's 1/12. I'm going to plug in 4, that's 1/16. And I have to add them all up. Don't forget to add these things. All right. So again, I'm just going to punch them in real quick. Got them punched in. Hit your math frac button. I'm getting this right. I'm getting 25/48. That wouldn't have been too bad. I probably could have found the least common denominator with that 48 down there. Okay, 2 more. 14. 14 says find the 53rd term. Now look at what kind of sequence that is. Is the difference the same? Are they adding the same thing, or are they multiplying the same thing? They are definitely adding 4. That means it's arithmetic. So I got to use the arithmetic formula, which is the first formula on your practice test. So I'm doing the 53rd term is the first term, which is -3, plus n minus 1. N is 53. So I'm going to put 52 times d. D is the difference, it's 4. So I'm just going to punch that straight in. 4 times 52 and -3. And I'm getting 205. So 205 would be the 53rd term of that sequence. And the last one right here, I'm going to be honest with you, number 15, this exact same question's on your test tomorrow. Like I didn't change a word, didn't change anything. What's the difference between arithmetic and a geometric sequence? There's a few things you could say here. You could say arithmetic or when differences are the same. Differences, I'm going to put are equal. Differences are equal. If it's geometric, the ratios are equal. Okay, or they're multiple. You can even write, like, if you want to, you can put, like, in arithmetic, the differences between the terms are the same. In geometric, they're multiplying by the same number every time. So again, arithmetic, they're adding the same number. Geometric, they're multiplying the same number. I kind of like what I wrote there. That's actually really good. I like that a lot. It's pretty short. So hope that helps. I'll be in my room if you need me before you take your test, so come see me. Good luck. Do good. It's important because it's early in the semester. It's important to keep up your good start. I got off to a great start last week. Keep it going. See you tomorrow.